In this video, I'm going to teach you one important concept in machine learning that is called overfitting and underfitting. I just want to make this topic long ago because this is very important topic and it will judge your performance of machine learning model based on your data. By learning and understanding this concept, you can be able to create machine learning models with more accuracy. In this video, I'm going to explain this concept with some straightforward and simple explanations so everyone can understand this concept very easily. Before starting this video, do like, share, comment and subscribe to support your creator. It helps me to motivate and it will bring you more new experiments and videos in data science. Let's get started. I just want to start this video by explaining two concepts. The first concept is underfitting. Underfitting means suppose you are training a machine learning model which doesn't have enough parameters to capture the trends in underlying data. And if you are training this type of machine learning for your business problem, it will give you high error rate on training performance and testing performance. At the time, your model will give you high number of loss amount on both datasets. This concept is called as underfitting. Next one is overfitting. In overfitting, our machine learning model performs more accurately on training data. In the validation data, it doesn't capture your target properly. Suppose if you are training a deep learning model with images, the model that you programmed must need to recognize the patterns between the data. Then only it will perform good on testing side. But overfitting happens when your model doesn't recognize the patterns in your data. Instead of understanding the patterns, it will generalize your image data. It means your model will perform on those particular data. It doesn't perform good on the testing side. So this is the end of theory part. Let's start the practical part. The practical explanation, I already created one CNN deep learning model. With this example, I will explain you how to identify those issues. And I already explained the CNN model architecture in this video. And if you want the model explanation, you can go and check this video. It is very useful for you to understand the CNN structure in a better way. In the first cell, I imported all the necessary libraries for this project. I'm going to build this deep learning model using Keras and TensorFlow. So I imported all the modules which are particularly needed for my CNN model building. In the next step, I declared scaling values for my data. Understand these variables are just variables. We don't process any data here. We will use this variable in the next step. Before moving into further, let's take a look at our dataset. We have two divisions here, test and train. The training dataset, I have two labels. Those are pizza or not pizza. Pizza column contains the images of pizza and not pizza column contains images of different foods rather than the pizza. I'm going to use this dataset to measure the overfitting and underfitting loss. So let's back to the code. In this step, we are preparing the data for training and testing operations. I will explain the important parameters here, and if you want an in-depth explanation, check out this video for more understanding. Okay. In the target size parameter, I set some numbers. These numbers will perform the cropping operation. We are dealing with image data, so the image dimension could be different for different images. We are setting up this parameter here to shape the different image data into different shape. And the next one is the class mode parameter. It explains our data type. Here we have the labels such as 0 or 1. 0 means it is pizza image, 1 means it is not pizza image. That's why we are using the class mode parameter. It will automatically label your data based on the instruction that you given. So that's all about the data preparation section. Let's move to the model section. In the model section, I just created this CNN structure. I haven't done any changes in the model structure and its parameters. I just copied this model structure from one of my video so I can explain the fitting issues much better. After that, I set my compilation parameter and I started my model training process. The model training process will take some time. I will see you on the model evaluation section. So in the model evaluation section, we are going to check the performances of our model. For evaluation, I called model.evaluate function here. First, I called this function against the unseen data. Technically, that is our test data. So look at this, we got some numbers and I did the same procedure against the training data. So now we got these numbers. What these numbers are actually saying. Here we got testing loss around 0.53 and training loss is around 0.17. This means our model is overfitted. And this model performed good in training data. So look at the training accuracy, we got 0.94. So it is performing good on training side. If you look at the testing data set, we got 0.75 testing accuracy. If we need to improve this model further, we should have to customize the parameters in model. We should be suitable to this data set. We can add or drop some layers in our model. Otherwise, we can increase more data to the model. It will add more complexity to the model and it definitely reduce the overfitting issues here. I hope you understand this video much better. It is one of the simplest and practical way of understanding the fitting issues in modeling. In some other video, I will explain about how to solve the overfitting and underfitting issues in modeling. The prime focus of this video is how to identify the fitting issues in modeling. Hope I will see you on next video with resolving these issues. Okay, so thanks for watching and thank you. See you on next another video.